Hello. So, we are going to just test everything that we've done. These are just some review questions. It's not a test, it's just some questions. But these are a great place to test all the things that you've learned, hopefully learned in the previous few lessons. So, start us off. I just want you to give me an equation. For some of them, there's more than one correct answer. So, yeah, just give me one. What's an equation that has energy as the main subject? What is an equation for power? What is an equation for speed? What is an equation for velocity? And what is an equation for force? If you can do ones relevant to this topic, it's even better. So pause, write down an equation for each of those, and then unpause when you're done. Okay, so energy. Well, there are loads of different energies. We can have kinetic energy, which is half mv squared. You can have gravitational potential energy, which is mgh. We could just have work done, which is just energy change, which is force times distance. Yeah, that's plenty. Power, the simplest power, is just energy over time. Speed, slow. Speed is distance over time. Difference between speed and velocity is obviously direction. So velocity is displacement over time. So displacement is directionally important. And force is equal to mass times acceleration. That's the old Newton's second law. But you knew that. Okay? If you had different ones, I'm sure they were right. You can check the back of your planner or just the Tinternet. But I'm sure you did great. So these are just questions. I'm going to talk through some of the questions to kind of help you along. If the questions are in blue like this, they're kind of for everybody. As you get towards the end, we have the higher tier ones that have this kind of colouring. So hang on, let me just double check. Don't want to end up giving you false information. Okay, that was correct. So, question number one, copy the table and match the quantity and its unit by ticking the correct box. So, for example, if you believe, let me check the pens back on because I just exited for a second. If you believe force is actually measured in watts, you might put a tick here. That's not how you do a tick, that's a tick. Hint is not, so don't do that. But that's how you do. Nice and simple. Copy out that, just put a tick in the correct row. Force is measured in, momentum is measured in, power is measured in, and work is measured in. All the correct answers are there, there's no trick. Calculate the force needed to produce an acceleration of 2 meters per second for a skateboarder of 40 kilograms. So in the starter, we had an equation that linked force, mass, and acceleration. Go back and check. Write down which of Newton's laws you used to calculate the force. I just said it in the starter. One of the forces acting on the skateboarder is the force of the earth on the skateboarder. Write down the other force in that interaction pair. I did a whole lesson on the free body force diagrams and interaction pairs. So that's Newton's third law. If object A exerts a force on object B exerts an equal and opposite force on object A. Oh, I've just told you the answer to part 2. There is one of Newton's laws that you have not used in this question. Which one is it? Write it down and write a question based on Newton's first law. Ooh, go on, use your brain. Most of you, I bet, won't do that. Was actually probably be the most beneficial question of all of them. Write a question related to that law. Explain the difference between work and power. And then when it says work, it means work in the sense of physics, not like you're doing work on your computer. Calculate the work done. If a jet ski moves a distance of 20 meters using a force of 10 kilonewtons, it takes a jet skier 3 seconds to travel 20 meters. Use your answer to B to calculate the power. We've got a force, we've got a distance, we've got a time. You can work out all the things. A hoist is used to raise up bricks to a high level on a building site. Here you have 120 kilograms of bricks and a 10 kilogram cage. That's important. They're lifting it 8 meters. Calculate the total weight in newtons, weight is newtons, of the bricks and the cage. They give you the gravitational field strength as 10. Calculate the work done by raising the cage of bricks 8 meters. It takes 10.4 seconds for the hoist to raise the cage 8 meters. Calculate the power in watts produced by the hoist. The average momentum of the cage of bricks as it rises to 8 meters per second. You need to use all of those equations from the starter, and you need to use the momentum one. So now we're into the slightly higher ones. So these ones will be trickier. If these are too much, it's okay. But it's a really good thing for you to practice. Draw a free body diagram for a balloon floating in a bucket of water. Remember, when you're doing the free body diagrams, you do the non-contact forces first, then the contact forces, and then just pick the object. You push the balloon down into the water and hold it there. Oh, horrible. Draw the free diagram for the balloon now. Use the free body diagram to explain the motion of the balloon at this moment. Note, it might not be moving. Use a free body diagram to describe and explain the motion of the balloon when you let it glow. Glow, go, go. And explain how Newton's law apply to the 3 situations observed. Explain how the International Space Station can be moving with a constant speed whilst a force acts on it and still obey Newton's laws of motion. Describe another situation in which a force acts on an object without changing its speed. Remember, if you have a resultant force, what are the 3 things that can change? 6 is define momentum. The equation is fine, but make sure you say what each part of the equation means. A father with a mass of 70 kilos skates across an ice rink at 3 meters per second. He picks up his stationary daughter, who has a mass of 30 kilos, and continues in the same direction. Calculate the speed of both of the father and the daughter after he picks her up. So he has a momentum at the start. She has 0 momentum at the start because she's not moving. Then, at the end, they are combined, so they're heavier, but their momentum must be conserved. They stop. They stand up, see each other, and then push each other apart. If the father moves off with a speed of 0.5 meters per second, calculate the speed the daughter moves off. Note her speed will be in the opposite direction. And remember, we talked about opposites, how you represent velocity when it's opposite, negative. Explain the difference in speeds. The firework and a firework display is set up on an island in the middle of a lake. A person sets off for the island on a boat with an engine that exerts a force of 100 newtons. The wind blows the boat at right angles to the direction with a force of 60 newtons. Calculate the magnitude of the resultant force on the boat. Diagram time. Spark that flies from the firework falls at a steady speed as it burns. Explain why. It's a steady speed. Why does something fall at a steady speed? A child watches the display sitting on a hill. Explain how you can resolve the forces of the earth on the child to explain why his motion does not change. And the last one, which I think is proper tricky. So if you can do that one, you will win like enough respect and house point and a signed photo of Mr. Williams. An eye bolt has 3 cables attached to it, so that's this thing. The cables are under tension as shown in the diagram. 6, 5, and T. 6 and 5 are at 45 degrees to each other. Use a free body diagram drawn to scale, so you'll need a ruler and a protractor, to find the tension in newtons that produces a resultant downward force of 10 newtons. So, here we go. That last one is hard, but have a go. Do a diagram, okay? Right, good luck. Love you. Bye.